Hello everyone. I'm going to do an example of how to prove that a quadrilateral is a parallelogram in the coordinate plane. Because we're in the coordinate plane, we have lots of tools available to us. We have all of our algebraic formulas that we can use. So we have things like the distance formula, we have the slope formula, and the midpoint formula that can help us. Now I do have options on how I want to do this. We have the definition of the parallelogram that we can use, or we have 4 different theorems that will also justify that it is a parallelogram. So the definition uses the parallel sides, which would be using the slopes. And for our theorems, we can show that the opposite sides are congruent to each other. We could show that one pair of opposite sides are parallel and congruent. We could also show that the diagonals bisect each other by showing that they have the same midpoint. So, lots of different options. For this example, I'm just going to show that this is a parallelogram by using the definition. So the definition is that the opposite sides are parallel to each other, so we just need to compare the slopes of these 4 segments. So the slope formula, the difference of the y's on top, and then the difference in the x's in the denominator. So we'll just go through, we'll do the slope formula for all 4 of the sides. So let's start with AB. Now on the graph, because I have this graphed out here, I could just count that. But it's nice to have some justification, just showing the algebra. So our slope, let's see, so we're going to have -2 minus 0 for our 2 y values, and then our 2 x values, -2 minus 0. That's going to be -2 over -2, which simplifies, that's a slope of 1. Alright, let's take a look at BC. We'll do the same thing. So our 2 y values, we have -4 minus a -2. And then our 2 x values, 2 minus a -2. Putting those -2's in parentheses, just want to make sure that I watch these negatives. Subtracting a negative turns into addition. So this is -2, or -4 plus 2, which is -2. 2 plus 2 is 4, so this simplifies to -1/2. Alright, 2 more, and hopefully these other 2 end up with the same slopes that we have already. So then CD, our slope, okay, -2 minus a -4 for the 2 y values, and then 4 minus 2 for the x values. This is -2 plus 4, so that's a +2 over 2, so that's 1. And then our last segment is AD, and our slope, -2 minus 0, and 4 minus 0. Having the point 0, 0 is nice to work with there. Okay. So as we can see, we have some slopes that match up. So AB and CD have the same slope. That means they are parallel to each other. And BC and AD have the same slope. So they're parallel to each other. And I'm just going to summarize that on the bottom here. So I'm going to say, so AB is parallel to CD, and BC is parallel to AD. Just that's the definition of parallel lines, basically. Well, there's a theorem that says that if they have the same slope, they're parallel. And then therefore, ABCD is a parallelogram. And the reason I know it's a parallelogram is just based on the definition. So ABCD is a parallelogram by definition. Okay. So that is just one way that we could approach this. As I was explaining in the beginning, we do have all of our theorems that we could use as well. So if I found the distance, so if I figured out how long AB was and CD was, I could use a theorem along with their slopes there. So the only thing that would change is your algebraic work would look a little different, and then your summary here, your justification for how you know it's a parallelogram, you just want to state which theorem you used. So here I'm just stating I used the definition. Maybe I used the converse of the opposite side theorem. So whichever theorem or definition you use, make sure you state that to finish up.